This is the story of a ghost that has traveled for millions, perhaps billions of years, to visit us. It's a story that challenges everything we thought we knew about comets, about the universe, and perhaps even about survival itself. This is the story of 3I Atlas, the anomaly from the void. Imagine the scene. It's July 1st, 2025. High in the bone-dry air of the Chilean Atacama Desert, one of the most remote and desolate places on Earth, a silent sentinel stands guard. A telescope, a marvel of human engineering, patiently sips starlight, its massive eye turned toward the heavens. For countless nights it performs its duty, cataloging the familiar dance of planets, asteroids, and distant galaxies. It's a routine, a predictable cosmic ballet. But on this night the routine is shattered. An automated alert flashes across a screen in a quiet control room. An anomaly. A single, faint point of light moving with a purpose and a speed that defies all local logic. Computers begin to churn through calculations, their processors racing to make sense of the impossible. The object is an intruder, an outsider. Its trajectory isn't the gentle looping ellipse of an asteroid or comet born in our own solar system. No, this is a one-way ticket. A searing hyperbolic arc that screams of an origin point light-years away. This visitor is moving at an almost incomprehensible 221,000 kilometers per hour. Let's try to put that speed into perspective. A rifle bullet travels at about 4,000 kilometers per hour. The fastest crewed spacecraft ever, the Apollo 10 capsule, reached a blistering 40,000 km/h during its return from the Moon. This object, this thing, is traveling more than 5 times faster than that. It is slicing through our cosmic neighborhood with such velocity that the Sun's immense gravity, the anchor of our entire system, is little more than a temporary speed bump. It will swing past our star and then vanish back into the interstellar darkness, never to return. This was only the third time in human history we had ever confirmed a visitor from another star system. We named it 3I Atlas. 3I for the third interstellar object, and Atlas for the telescope system that first flagged it. And at first, astronomers felt that familiar, exhilarating thrill of discovery. A new piece of the cosmic puzzle had just landed on our doorstep. But as they watched, and as more powerful instruments turned their gaze upon this fleeting guest, that thrill began to morph into something else. A deep, unsettling confusion. Because the speed of 3I Atlas, as astonishing as it was not the most shocking thing about it, not by a long shot. The true mystery was just beginning to unfold, and it was a paradox that would tie the greatest minds on the planet in knots. Have you ever felt like you were witnessing something that just shouldn't be possible? A moment that seems to break the rules of reality? Share that experience in the comments below. We'd love to hear about the impossible things you've seen. To understand the first great paradox of 3I Atlas, we need to talk about what comets actually are. Forget the majestic, solid-looking objects you see in pictures. The vast majority of comets are not solid boulders of ice. They are what scientists lovingly call rubble piles. Imagine gathering a huge handful of gravel, sand, and dust, and then packing it together with a bit of slushy, dirty snow. Now imagine that pile is miles wide, held together by nothing more than its own incredibly weak gravity and the faint, sticky bonds of frozen gases. That is a comet. They are fragile, delicate congregations of cosmic debris, cosmic dust bunnies of immense size but very little structural integrity. Now, imagine taking that giant, fragile snowball and spinning it. A slow, lazy spin, like our own planets, is fine. But what if you spin it faster, and faster, and faster? The same thing happens that happens on a playground merry-go-round when you spin it too fast. The kids on the edge feel a powerful outward pull, the centrifugal force. Spin it fast enough, and they'll be flung off. This is the cosmic precipice on which 3I Atlas lives its entire existence. When astronomers managed to get a clear reading on the comet's rotation, they found a number that made them check their calculations again and again. The object spins on its axis once every 16.8 hours. Now, 16.8 hours might not sound particularly fast to you or me. After all, Earth does it in 24. But for a massive, fragile rubble pile comet, a 16.8-hour day is terrifyingly fast. It is, quite literally, the breaking point. The spin is so rapid that the outward centrifugal force pulling the comet apart is almost perfectly, impossibly balanced by the inward pull of its own gravity and its flimsy internal strength. Think of it like this. Imagine a ballerina in the middle of a pirouette, spinning faster and faster. There is a point where the sheer speed would overcome the strength of her own body. She would simply fly apart. 3I Atlas is holding that exact pose, on that exact ragged edge of self-destruction, and it has been doing so for who knows how long as it tumbled through the void. To give you a comparison, the well-studied comet 67P Churyumov-Gerasimenko, which the Rosetta mission orbited for years, rotates once every 12.4 hours. But it's much smaller and appears to be a bit more solid. The legendary Halley's Comet has a wobbly, chaotic rotation that averages out to about 7 days. These are leisurely, safe speeds. 3I Atlas, on the other hand, is a daredevil. It is living life on the knife's edge. If it were to spin just a tiny fraction faster, a 16.7-hour day instead of 16.8, it would begin to shed material from its equator. Faster still, and it would completely disintegrate into a cloud of dust and ice, a fleeting memory in the solar wind. And yet, it doesn't. It remains whole, stable, a spinning paradox held together by a cosmic thread. This raises the first profound question of our interstellar visitor. How? How can a loosely held together pile of rubble endure such immense, relentless, self-destructive forces? Was it born this way, on the brink of oblivion? Or did something happen on its long journey through the darkness between the stars to spin it up to this critical limit? It's like finding a spinning top made of soap bubbles, perfectly balanced, that has somehow survived a hurricane. It makes no sense. It's a physical impossibility that is, against all odds, very, very real. And the deeper scientists looked, the more impossible it all became. What in your life feels like it's spinning on that knife's edge, held in a delicate balance? It could be a challenging project, a relationship, or even your own personal state of mind. It's a state of high tension, but also sometimes a state of incredible focus and strength. If the comet's spin was a riddle, its movement was a full-blown magic trick, a defiance of the laws of cause and effect that was happening right before our most powerful eyes in the sky, the James Webb Space Telescope. When the JWST turned its golden hexagonal mirror towards 3I Atlas, it wasn't just looking at a point of light. Its incredibly sensitive instruments were designed to taste the very essence of the object, to analyze the cloud of gas and dust surrounding it, called the coma. And what it tasted was staggering. The telescope detected that 3I Atlas was furiously outgassing. As the faint, distant warmth of our sun touched its surface, the frozen carbon dioxide ice was turning directly into gas, erupting into space in powerful jets. This wasn't a gentle hiss. It was a constant, violent explosion. The JWST measured the comet spewing out 150 kilograms of carbon dioxide gas every single second. That's like launching the weight of a full-grown person into space, every second, without end. Now here's where the laws of physics come in. Think about a simple fire extinguisher. When you squeeze the handle, the compressed gas rushes out of the nozzle. What happens to the extinguisher itself? It pushes back into your hands. This is Newton's third law of motion. For every action, there is an equal and opposite reaction. These jets of gas erupting from a comet work the same way. They are like tiny rocket engines. When they fire, they should push the comet around. This push is called non-gravitational acceleration. It means the comet's path shouldn't be dictated purely by the gravity of the Sun and planets. It should be nudged and jostled off course by its own outgassing. We see this with our own solar system's comets all the time. It's expected, it's normal, but 3I Atlas ignores the rules. Despite unleashing a continuous thrust equivalent to a powerful engine, the comet's trajectory was pristine. It followed a path dictated purely, and with mathematical perfection, by gravity alone. It was as if the 150 kilograms of gas per second were having no effect at all. Imagine seeing a sailboat with its sails full in a gale-force wind, yet sitting perfectly still on the water. It's a contradiction. It's an illusion that shouldn't be possible. The mystery didn't stop there. These powerful jets of gas don't just push a comet. They can also make it spin, or change its spin. If a jet is firing off-center from the comet's core, it creates a torque, a twisting force. It's the same principle as spinning a pinwheel by blowing on its edge. Over time, these torques should absolutely change the comet's rotation rate. It should either speed up, likely past its 16.8-hour breaking point, or slow down. Yet again, 3I Atlas showed an impossible stability. Observations that spanned months, covering a vast portion of its journey through our inner solar system, showed that its spin period was locked. 16.8 hours. Not 1679. Not 1681. It was as constant as a ticking clock. So now we have two impossibilities for the price of one. A comet that is subject to powerful, continuous forces that it simply ignores. It feels no push. It feels no twist. It sails along its gravitational path with its impossibly fast spin, all while blasting out tons of gas every minute, seemingly in total violation of the fundamental principles of motion. How can this be? Is the comet a celestial magician, practicing a form of cosmic sleight of hand we can't comprehend? Are the forces somehow canceling each other out with a precision that seems utterly unnatural? This was no longer just a curious object. It was a profound scientific enigma. It was a visitor that was not just showing us a piece of another solar system, but was seemingly showing us that our understanding of how the universe works might be incomplete. The paradox of its motion and spin was a direct challenge to the foundations of celestial mechanics, and the clues to solving this mystery lay buried in its very soul, its chemical fingerprint. In our quest to understand the cosmos, one of our most powerful tools is spectroscopy. It's a beautiful and elegant technique. By capturing the light from a distant object and passing it through a prism, we can spread it out into its rainbow of constituent colors. But within that rainbow are tiny, dark lines, gaps where specific colors are missing. These lines are absorption bands, and they are a perfect fingerprint. Each element, each molecule absorbs light at its own unique frequencies. Those dark lines tell us exactly what an object is made of, even from billions of miles away. It's how we know stars are made of hydrogen and helium. It's how we know the clouds of Jupiter contain ammonia. And it's how we learned that 3I Atlas is fundamentally, deeply alien to our home. When we look at the comets born in our own solar system, from Halley to Hale-Bopp to the hundreds of others we've studied, they have a consistent recipe. They are, for the most part, dirty water ice snowballs. Water ice is the dominant ingredient, the foundation of their being. 3I Atlas breaks the mold completely. Its spectroscopic fingerprint showed it to be overwhelmingly rich in carbon dioxide ice, dry ice, with a startling scarcity of the water ice that is so common here. This wasn't just a minor difference in flavor. This was a completely different chemical recipe. It tells us that wherever this object was born, the conditions were radically different from the primordial cloud that formed our own sun and planets. It must have formed in a place that was perhaps far colder, or had a fundamentally different chemical makeup, an environment where carbon dioxide, not water, was the king of ices. But the true chemical bombshell, The signature that made astronomers lean back in their chairs and stare at their data in disbelief was found in its coma, that cloud of gas surrounding it. They detected the clear, unmistakable fingerprint of atomic nickel vapor. Now, finding heavy elements like nickel in a comet isn't unheard of. They are usually locked away in dust grains. But finding it as a vapor, a free-floating gas, is strange. What made it truly bizarre, what made it a chemical signature never before seen in the history of astronomy, was what wasn't there. In our solar system, and in the universe as we know it, nickel and iron are cosmic brothers. They are forged together in the hearts of dying stars and are almost always found together in meteorites and asteroids. Where you find one, you should find the other. The coma of 3I Atlas contained nickel vapor without the expected corresponding presence of iron. This is a chemical impossibility based on everything we know. There is no known natural process in our solar system that can separate nickel from iron with such efficiency. It's like finding a forest with only oak trees and no other kind of tree anywhere. It's like finding a beach with only blue grains of sand. It points to an origin so exotic, a formation process so alien that we don't even have a model for it yet. This chemical fingerprint was the ultimate confirmation. 3I Atlas was not just a tourist passing through. It was an emissary from a completely different chemical and physical regime. Its body, its motion, its very substance were all telling the same story. I am not from here. And so the scientists, faced with a spinning, impossibly stable, chemically bizarre object that defied the laws of motion, had to get creative. They had to dream up theories that were as strange as the object itself. They had to try and explain the inexplicable. And from their debates and computer models, three extraordinary possibilities emerged. The first leading explanation is perhaps the most elegant, and in a way, the most poetic. It proposes that 3I Atlas is not a passive object at the mercy of physics, but an active, self-regulating system that perpetually saves itself from destruction. Let's go back to that knife's edge, that 16.8-hour spin that is right at the breakup limit. In this model, that limit is not a threat. It's a safety valve. The comet survives because it is constantly on the verge of falling apart. Here's how it would work. Remember those powerful gas jets that should be making the comet spin faster? In this theory, they do. The jets fire, the torque is applied, and the comet's rotation begins to accelerate even just a little bit. It starts to spin in 16.79 hours, then 16.78. It is now crossing the red line. It is entering the breakup zone. But instead of catastrophically exploding, something gentle happens. As the centrifugal force at its equator begins to overpower its feeble gravity, a small, steady stream of dust and pebbles begins to lift off the surface. It's not an explosion, but a delicate shedding. A constant, tiny trickle of material is ejected from its equator, out into space, in the direction of its spin. Now think about what happens when a figure skater, spinning rapidly with their arms pulled in, extends their arms outward. They slow down. This is the principle of the conservation of angular momentum. By shedding that stream of mass, by extending its arms, 3I Atlas is carrying away its own angular momentum. This act of shedding material creates a natural, gentle braking effect. The result? The rotation slows back down. It drifts from 1678 back to 1679, and then settles again at its stable 16.8-hour equilibrium. It's a perfect feedback loop. The comet is a self-regulating engine. The very force that threatens to destroy it, the spin-up from its gas jets, triggers the exact mechanism needed to counteract that force. It saves itself from death by flirting with it. It is a system in a state of perpetual dynamic equilibrium. It survives by constantly, gently falling apart just a little bit. This theory is beautiful because it solves two of the main problems at once. It explains why the comet doesn't spin itself to pieces, because it has a built-in brake. and it potentially explains why we don't see any non-gravitational acceleration. Perhaps the shedding of mass from the equator is so uniform, so perfectly balanced around the comet's waistline, that the net push on the comet is zero. The forces all cancel out with an astonishing natural precision. Is there a lesson for us here? I think so. How often in our own lives do we face pressures that threaten to spin us out of control? Stress from work, personal challenges, overwhelming responsibilities. Perhaps the lesson from 3i Atlas is that sometimes stability isn't found by resisting the pressure, but by learning how to let go, by shedding the non-essential, by releasing that extra momentum in a controlled way. We can slow ourselves down and find our balance again, right on the edge of what we think we can handle. It suggests that sometimes our greatest strength is found not in being unbreakable, but in being adaptable. The second theory is just as compelling and takes us in a completely different direction. It asks a simple, powerful question: what if we're not looking at a single object at all? This hypothesis suggests that 3i Atlas is actually what's known as a contact binary. Imagine not one but two smaller cometary bodies. In the distant past, they had a gentle, slow-motion collision, and instead of shattering, they fused together, connected by a narrow neck. The resulting shape would be something like a snowman or a dumbbell. We have actually seen an object like this in our own solar system. The Kuiper Belt object Arrokoth, visited by the New Horizons spacecraft, looks exactly like two pancakes stuck together. In this scenario, the 16.8-hour period that we observe is not its spin at all. It is the orbital period of these two lobes revolving around each other, locked in an eternal, cosmic dance. This clever reinterpretation solves the mysteries in a completely different way. First, the stability against the spin. A dumbbell-shaped object has a much higher inertia than a single spherical object of the same mass. It is far, far more resistant to being twisted or having its rotation changed. Those gas jets that should be creating a torque would have a much harder time altering the stately, stable orbit of these two massive lobes. The system would be inherently more robust, less susceptible to being spun apart. Second, the lack of non-gravitational push. With a contact binary, you have a much more complex surface. It's possible the gas jets are being channeled in very specific ways. Perhaps they are firing primarily from the poles of the object, perpendicular to the direction of motion, so they push sideways but not forward, resulting in no net change to its trajectory. Or even more elegantly, perhaps the outgassing is symmetrical. For every jet firing from one lobe, a nearly identical jet is firing from the other lobe in the opposite direction. The two forces would perfectly cancel each other out. The comet would be pushing against itself, resulting in a net force of zero, leaving it to follow its perfect gravity-only path. This theory paints a picture of partnership and hidden complexity. On the surface, we see a single, impossible object. But beneath that first impression lies a more intricate truth, a story of two companions bound together, whose combined nature allows them to achieve a stability that neither could alone. Their mirrored forces create a perfect silent equilibrium. It's a powerful metaphor, isn't it? It makes you wonder what unseen complexities govern our own lives. Perhaps the challenges we face, the forces that seem to push and pull us, are more balanced than we realize. Perhaps our own stability comes from a hidden, dual nature, a partnership of strengths and weaknesses, of logic and emotion, that when working together, create a whole far more resilient than the sum of its parts. It suggests that sometimes the solution to a paradox is to realize you're not looking at the whole picture. The truth is often more complex and more beautiful than it first appears. What do you think is more likely so far? The self-regulating engine, constantly shedding its skin to survive, or the hidden partnership of the contact binary? Let me know your vote in the comments. The third and final hypothesis is by far the most profound, the most epic, and the most humbling. It suggests that 3i Atlas is not what we think it is. It is not a primordial comet, formed from the leftover dust of a new star. Instead, it is something much, much older. It is a relic, a piece of shrapnel from a planetary-scale cataclysm that happened in another solar system billions of years ago. This theory dares to imagine that we are witnessing not a comet, but a shard of a long-dead world. Think about the planets in our own solar system. The larger ones are differentiated. This means that when they were young and molten, the heavy elements like iron and nickel sank to the center to form a metallic core, while lighter materials like rock and on the outer worlds, ices like water and carbon dioxide floated to the top to form a mantle and a crust. Dwarf planets in the outer reaches of a solar system, like Pluto, could be similarly structured. A rocky or metallic core surrounded by a massive, miles-thick crust of various ices. Now imagine such a world in a distant star system. A large, differentiated dwarf planet. Its surface a vast, frozen expanse of carbon dioxide ice. It orbited its star peacefully for eons. But then, disaster. A collision. Another large body, perhaps a rogue planet, smashed into it with unimaginable violence. The world was not just cratered, it was shattered, obliterated. The cataclysm would have peeled its icy crust away from its metallic core, sending trillions of tons of frozen fragments flying out into interstellar space. And for billions of years, one of those fragments has been tumbling through the void. A lonely, silent traveler, carrying the memory of its own violent birth. That traveler, this theory proposes, is 3I Atlas. This single breathtaking idea explains almost all of the comet's bizarre features at once. Its chemical composition, perfectly explained. If it's a piece of the icy crust of a differentiated world, then it would naturally be overwhelmingly rich in crustal ices like carbon dioxide, and poor in the water ice that might have been in a deeper layer. And the nickel without iron mystery? This is its most powerful piece of evidence. In a differentiated planet, the iron would have sunk to the core. The nickel, while also heavy, can sometimes bond with other elements and remain in the upper layers. A cataclysm that stripped the crust away would send fragments rich in these crustal elements, but poor in the core element of iron, out into the galaxy. The chemical signature that is impossible for a primordial comet becomes the natural fingerprint of a shattered planet, S-crust. Its immense mass? Scientists estimate 3I Atlas has a mass of at least 33 billion tons. This is enormous, an outlier that defies the statistical models of what size interstellar objects should be. But if it's a fragment of a much larger parent body, its size is no longer a statistical anomaly. It's a logical consequence of its violent origin. Its incredible structural integrity, allowing it to spin so fast. This too is explained. This wouldn't be a loosely aggregated rubble pile. It would be a solid, contiguous chunk of ice, forged and compressed under the gravity of a planet for billions of years. It would be far stronger, far more resilient, and capable of withstanding rotational forces that would tear a normal comet to shreds. This theory transforms 3I Atlas from a curious comet into a tragic messenger. It is a tombstone adrift in the cosmos. It is a piece of a world we will never see, a sun we will never know. It whispers a tale of creation and destruction on a scale that dwarfs human comprehension. Every observation we make of it is a form of cosmic archaeology, studying the ruins of a celestial body that died long before our own planet even had life. We may be looking at the ghost of a world. And it makes you wonder, what other stories are drifting in the dark between the stars? What other messengers from lost systems are currently on their way, carrying their own silent, epic tales? We are just now beginning to realize that the space between stars is not empty. It is a graveyard, and it is a library, filled with the fragments of distant histories. So here we stand, at the edge of our understanding, gazing at this impossible visitor. A comet held together on the edge of destruction, that ignores the very forces that should tear it apart, with a chemical makeup from an alien realm, and an origin story that might be more epic than any we have ever imagined. Whether it's a self-regulating engine, a celestial partnership, or a shard of a shattered planet, 3I Atlas is more than just a scientific curiosity. Like all great explorers, it brings back lessons from the unknown, reflections that we can bring into our own lives here on Earth. The first lesson is one of that resilience on the edge. 3I Atlas exists in a state that our science says is impossible. It is perpetually on the brink of its own destruction, yet it endures. It's a powerful reminder that sometimes we find our greatest strength not in safety and comfort, but right at the very limit of what we can handle. Life will often spin us faster than we think we can bear. But like the comet, we might just have a hidden strength, a way of holding together, that we don't discover until we're tested. It teaches us that our breaking point might be much further away than we think. The second lesson is about embracing mystery. We live in an age that craves answers. We want everything explained, categorized, and filed away. 3I Atlas is a gift of pure mystery. It defies our neat explanations. Every answer we propose only leads to more profound questions, and there is a deep and profound joy in that. It reminds us that the universe is not obligated to make sense to us. Its beauty lies in its infinite, baffling complexity. The true adventure of science and of life is not in having all the answers, but in learning to ask better questions and to stand in awe of the things we do not yet understand. And finally, the third, and perhaps most important lesson, is about connection. For a few brief months, this object, this shard of a potential other world, has united astronomers and stargazers around our entire planet. It traveled for billions of years in silent solitude, and for a fleeting moment its journey intersected with ours. It reminds us that we are not isolated. We are part of a vast, interconnected cosmic story. The atoms in our bodies were forged in stars that died long ago, just as 3I Atlas may have been forged in a world that died long ago. We are all fragments of a larger history, carrying pieces of the past with us on our own journey through time and space. This comet, this lonely ghost, reached across the unimaginable gulf of interstellar space and, for a moment, made our own world feel a little less lonely and a lot more magical. So as you go about your day, I want you to carry the story of this impossible visitor with you. When you feel like you're spinning at your limit, remember the comet that holds itself together on the knife's edge. When you face a problem that seems to have no solution, embrace the mystery and the joy of not knowing. And when you look up at the night sky, remember that you are looking into an ancient library of untold stories, and that you too are a part of that grand, cosmic narrative. Thank you so much for joining us on this journey to the farthest reaches of our understanding. I hope this story has filled you with as much wonder as it has for me. Please, take care of yourselves, and take care of each other. Be well, stay curious, and never stop looking up. And if you enjoyed this journey into the unknown and want to explore more of the universe's greatest mysteries with us, please consider subscribing to the channel. It helps us continue to bring these stories to you. We'll see you next time.